Classic DC superhero The Flash is known for running at speeds even faster than the speed of light. He does this by harnessing the Speed Force, an all-encompassing omni-energy, allowing him to control and alter the laws of physics. But could he run at these speeds in real life? My first question was, could the Flash accelerate to the speed of light almost instantly? For my calculations, I gave the Flash 10 centimeters to accelerate from 0 meters per second to the speed of light. Using the following kinematic equation, I calculated that the Flash's acceleration would be around 4.5 times 10 to the 17 meters per second squared. That means the Flash accelerates 3.57 times 10 to the 16 times faster than the Porsche 918 Spyder, the current fastest car in the world, and is equal to around 4.6 times 10 to the 16 Gs. Then, using the mass of Wally West, the Kid Flash, of 86 kilograms, I calculated that the net force required would be 3.87 times 10 to the 19 newtons. Using the equation of energy equals force times distance, I calculated that the energy produced would be 3.87 times 10 to the 18 joules. To put this in perspective, the largest bomb ever detonated was at Tsar Bomba, which created 50 megatons of energy, or 219 petajoules. The Flash, however, produces 3.87 exajoules of energy, 18 times greater than that of the Tsar Bomba. My next question was, what would it take for the Flash to continue running at the speed of light? To start, I found that the average number of calories burned per mile for a person of the Flash's size is 125 calories per mile, or 77.64 calories per kilometer. So since the Flash is running the speed of light, he runs 300,000 kilometers per second and burns over 23 million calories per second. That's the equivalent of eating over 90,600 Big Macs per second. Also, using the common idea of needing a 3,500 calorie deficit to lose 1 pound, he would lose around 6,655 pounds per second, or an equivalent of 37 times my mass per second. To calculate the number of steps taken per second to run at the speed of light, I gave the Flash a stride length of 2.18 meters, around average for his height, and calculated that he would take over 137,600,000 strides per second, which is 29,400,000 times more strides per second than Usain Bolt. In conclusion, after calculating that the Flash would need to accelerate at a rate of 4.5 times 10 to the 17 meters per second square, require 3.87 times 10 to the 19 newtons of force, and produce 3.87 times 10 to the 18 joules of energy to accelerate to the speed of light almost instantly, as well as requiring 23 million calories per second and 137.6 million strides per second to run at the speed of light, it is not plausible for the Flash to accelerate to the speed of light almost instantly and to maintain this speed without the Speed Force in real life.